Everybody, welcome back to another video in our first unit on EDA. In this video, we're going to go through a brief aside on numerical precision and making copies in Python. So if you recall from the previous video, we had this list of ratings and we computed the average and it was 3.83 repeating and then 5 at the end here. So for this video, I'm just going to call a list new ratings. I'm going to slightly update the numbers. Reason for this is the average, like the actual mathematical average of ratings from the previous video doesn't have a finite decimal value. So it's 0.833333 repeating forever. So really to show you kind of some issues with numerical precision, this example is going to be a little bit nicer. So what do I mean by that? Well, first let's start by taking the average of new ratings. So maybe if you have a moment, press pause on this video and compute the average on a calculator. You'll see that it's exactly 3.7. But now let's see what happens when we compute the average using Python. So I'm going to say take the sum of new ratings, divide by the length of new ratings. So you can see here we get 3.70000, a whole bunch of zeros, and then 6. So like I said, the actual answer is 3.7 exactly. So kind of what's going on here? Well, this has to do with the fact that we're using floating point numbers. So this, if you're unfamiliar with that term, you can think it just means decimal places. And there's a lot of errors with precision when we're dealing with floating point numbers. So you should never expect these calculations to be 100% precise. And kind of just to illustrate that, you should also be very careful checking equality. So for instance, if I take this calculation, and I know mathematically it should be exactly 3.7. Notice what gets returned here is false. So all that to say is you should be very careful when you're using double equality. It tends to work best for integers. For floating point, like we saw in Math 9, other videos on this channel, it's better to use kind of an error tolerance here. So I could say, is the difference between the computation on the left and the number on the right smaller than some error threshold? And in this case, we know the difference is very, very small. It's this number here. So again, just an example of where to be very careful with checking for equality. Maybe the most famous example of numerical precision errors in Python is the following. So if I have 0.1 plus 0.1 plus 0.1, well, I know this should be 0.3, but Python is telling me that's false. So if you're curious and you'd like to do a little bit more, one thing I can suggest is try writing 0.1 in base 2 and see if you notice anything interesting about it. So little hint. Otherwise, the second part of this video, I just want to give a warning about making copies. What do I mean by this? Well, okay, let's start by taking a look. I guess we already have new ratings here. Let's say I want to append something to it, but first I'll create a new list. So I'll call this, let's say, my list 2. I say, what if it's equal to new ratings? And then you can imagine, well, what if I want to append something to my list 2? So maybe I'll add my name. So I'll say my list 2.append, and we'll put Yasmin. So, okay, no error there. Let's take a look at my list 2. And we can see, okay, that's looking good so far. But then here's something strange. So notice what happens now if I call new ratings. So notice new ratings also got changed. So what's happening here is my list 2 points to the same location in memory of new ratings. So when new list gets changed, my list 2 gets changed, so does new ratings. So to avoid this error, what we want to do is make copies instead. So what I mean by that is let's try my list 3. And let's say this is equal to new ratings, but I'm going to make a copy. So I say .copy. And then I can say my list 3.append. And let's say I append Peter Anteater. So let's take a look. Here's my list 3. So remember, we said it was new ratings.copy, and new ratings has Yasmin at the end, but now we have Peter Anteater appended as well. But let's see if new ratings got changed. Nope, it didn't. So that's kind of the effect of making the .copy here. You can think of this as creating a brand new copy from new ratings. So my list 3 is distinct now from new ratings. All right, quick video, just wanted to talk about those two topics before we go into more about pandas in the next video. Thanks for watching, I'll see you there.